Hello everyone. Today we are going to talk about something that separates a regular Spark developer from someone who truly understands the engine. Adaptive query execution. So if you have faced performance issues in Spark and you know that they are rarely about syntax, then they are about the execution strategy. AQE is one of the biggest execution improvements introduced in Spark 3. So, if you understand this deeply, interviews become easier and production debugging becomes clearer. So, let's begin with why it was even needed. Now, before Spark 3.0, Spark created the physical plan only once. It used the catalog statistics, estimated the row counts, and the cost based assumptions. And once the execution started, the plan was frozen. Now think this practically. What if the statistics were outdated? What if today's data distribution is completely different? What if the optimizer estimated 50 MB, but the actual size is 2 MB? What if there is a severe skew in one of the partitions? So Spark could not correct itself. It trusted its estimates. And that rigidity was the core problem. AQE was introduced to allow Spark to react to reality. In simple words, Spark moved from static thinking to adaptive thinking. Now, what is AQE? Adaptive Query Execution. This allows Spark to reoptimize the physical plan during execution using the actual shuffle statistics. Notice the precision here. It does not change the logical plan. It does not rerun the catalyst logical optimization. It modifies only the physical execution plan. So this distinction is extremely important in interviews. AQE is runtime physical correction and not the logical optimization. Now, AQE works only at shuffle boundaries. So, this is critical. If you remember only one trigger condition, remember this shuffle boundary. Now, why shuffle boundary? Because shuffle materializes immediate data. Now, once a shuffle stage completes, Spark now knows the actual partition size and the real row counts. So estimates become facts, and only then can Spark safely reconsider the earlier decisions. So no shuffle means no adaptation. Remember that. Now internally, Spark wraps the physical plan inside the AdaptiveSparkPlanExec. And this is the controller. It replaces the original Spark plan node during the execution. So it monitors the shuffle stage completion and it collects the runtime statistics. It evaluates whether the remaining physical plan should change. And it produces the final adaptive plan that you see in Spark UI. So AQE is implemented as a physical plan wrapper and not as a new optimizer phase. So that architectural detail is what differentiates a service level understanding from an engine level understanding. Now, let's look at the join correction. Initially, Spark chose a join strategy based on the estimated size. Suppose it estimated that the table was 50 MB and it chose sort merge join. Now execution started, shuffle completes. Now Spark observes that the actual size is 2 MB. So broadcast is possible. So without AQE, you are stuck with sort merge join. But with AQE, Spark replaces the sort merge exec with the broadcast hash join exec. So logical plan remains unchanged. Only the physical operator changes. So that is runtime intelligence. This is one of the common real world performance improvements that you'll see. Now, how join rewriting actually happens. This is a sequence that is structured. Shuffle completes. Map output statistics are collected. The cost model reevaluates the join strategy using the real data. If a better strategy exists, then the physical node is replaced. This is controlled mutation. And it is not guesswork, not randomness. It's data-driven correction. So Spark is not experimenting here. It's reacting to the measurable statistics. Now the default shuffle partitions are 200. And now imagine that the total shuffle data is 100 MB. Each partition becomes tiny and you end up with too many small tasks. High scheduler overhead and inefficient CPU usage. Now after shuffle completes, AQE calculates the total shuffle size divided by the target partition size. And then it reduces the partitions dynamically. So 200 may become 8 and only the downstream stages are affected. So completed stages are not modified. This is adaptive parallelism. And in ETL workloads, this alone can significantly reduce the execution time. Now, skew join optimization is a very important topic. Now, as we know, the skew is one of the most dangerous runtime issues. Imagine one partition is 10 GB and the other is 20 MB. So one executor runs much longer, others sits idle. Now the stage completion time becomes dominated by just one task. And if you have ever seen one task running forever while the others finish quickly, then that's simply skew. The AQE detects skew and it uses two conditions. The partition must exceed the absolute threshold and it must exceed the median partition size multiplied by the skew factor. Now, if both are satisfied, only then the skewed partition is split. Multiple reducer specs are created, and the smaller side of the join is replicated. So execution becomes parallel. Non-skewed partitions remain untouched, and this is the targeted correction. Now, if shuffle data resides locally on an executor, remote fetch is unnecessary. So AQE replaces the shuffle reader with the local shuffle reader exec. So this is what is allowed locally. And this reduces the network input output. It reduces the fetch wait time and it improves the performance in large clusters. So small optimization, but meaningful in production, especially in large distributed clusters where network cost is non-trivial. Now let's clarify something that the interviewers love to ask. So cost-based optimizer works before execution and it uses the catalog statistics. It influences the logical and the physical planning. And it also predicts cost. Now, AQE works during the execution and it uses the actual shuffle statistics. It modifies only the physical plan and it corrects decisions based on the reality. So CBO improves the initial plan while AQE improves the executed plan. Again, CBO is predictive while AQE is reactive. So if you explain this clearly, you sound like a senior engineer. Now what AQE cannot do? AQE has its own boundaries. It cannot modify the logical plan. It cannot fix badly written UDFs. It cannot fix the memory misconfiguration. It cannot modify the completed task. Again, it cannot optimize the non-shuffle operations. So understanding the scope shows maturity. Knowing limitation is as important as knowing capabilities. Now, how AQE appears in Spark UI, this is something that I'm not going to demonstrate here, but I would like you to do it and let me know in the comments. And this is how you should do. You need to go to Spark UI, open the SQL tab, click your query. At the top, you see the Adaptive Spark plan. And this confirms that AQE is active. Now you see initial plan and final plan. Now initial plan is what Spark created before execution. And final is what actually executed after runtime correction. Now, if both are identical, AQE did not need to modify anything. And if they differ, then adaptation happened. So never assume that AQE helped. Always verify in Spark UI. And the initial plan shows what Spark had planned. The final plan shows what Spark learned. And this is exactly how you are going to debug the performance in real production system. So now let's connect everything. So a data frame is created, a join is triggered, shuffle stage runs, map statistics are collected, AQE is evaluates the plan, and join strategy may switch. Partitions may be reduced. Skew may be handled. Remaining plan executes with correction. So the final adaptive plan completes. And this is what is the full life cycle. This is the full story from estimation to adaptation. Now AQE is enabled by default in Spark 3.2 and above. These are specific configurations for coalescing partitions, skew join handling, and local shuffle reader. So in production, tuning these thresholds can influence the behavior. But remember, AQE is not a substitute for understanding the partitioning. It is an intelligent assistant and it's not magic. So you still need to understand and have the good practices, like the engineering practices, uh, while doing the coding. Now, AQE gives massive gains when data is skewed. When daily data volume changes and when the joins are wide and heavy. When the shuffle sizes vary unpredictably and impact is minimal when the data is small and when there is no shuffle, when the job is CPU heavy. So, always evaluate the workload characteristics. Context always matters in performance engineering. Now imagine the initial plan shows sort merge join with exchange nodes. Now after execution, the final plan shows broadcast has joined and broadcast exchange. So that visual transformation confirms that the runtime adaptation happened. And seeing this once in Spark UI, it makes AQE feel real. And once you see this in a real job, you will never forget how AQE works. Now, Spark plans optimistically using the estimates. AQE corrects using the runtime reality. Execution becomes data driven instead of assumption driven. So, if you understand when AQE triggers and what it modifies and what it cannot modify, how to validate it in Spark UI, and how it differs from CBO. That you are no longer treating Spark as a black box. So you are reasoning about the engine. And that is exactly what the interviewers look for. And that is the level you should aim for a Spark engineer. So these are some of the interview questions that are listed here, which were answered in this video. So hope you find this useful. Do write in the comments, and thank you for watching. We'll meet in the next time. Thank you.